Okay, this is a lesson on simplifying algebraic expressions, and we already know what algebraic expressions are. They're a collection of numbers, operations, and grouping symbols, but most importantly variables. So this is an example right here of an algebraic expression, and in an algebraic expression, terms are the items that we add and subtract. What we want to really consider today is that there are items in an algebraic expression that can sometimes be put together, and when the items that we can actually put together are called like terms. And what like terms are, and just to review, terms themselves are the items we add and subtract. So in this particular expression, the terms of the expression are 2x, 3y, I'm going to separate them by commas, 5x, and anytime there's subtraction for a term, we're going to consider that to be a negative term. And so we're going to call that term negative 8x and 3x squared. Now, like terms, those are the items that we're going to be able to put together in an algebraic expression when we're what is called simplifying. Like terms are the terms, and again, these are your terms, the items that we add and subtract. They're the terms that have the same variable. So you'll notice we have x's, we have y's, and then for them to be like terms, they also have to be to the same power. So notice that this x does not have a power. It actually does have one, but we don't put it, the power of x here is 1, the power of y here is 1, this power of x is 1, but look all the way over here, this power of x is 2. So we would consider the like terms in this expression to be, so like terms for this expression are going to be 2x, 5x, and negative 8x. They are all terms that have the same variable, in this case x, taken to the same power, in this case 1. And then we also have two terms that have y's in them, also to the first power. And so we'll consider those y terms to also be like terms with each other. Negative 5y would be the other like term with the 3y. And the one term that doesn't have a like term is this 3x squared term. So these are your like terms. Through the process of showing you how to put like terms together, I'm going to be using these online, or these smartboard manipulatives. And so just to make sure we know what they are when I use them, when I have a single green little box like that, that's our most basic unit. That means one of something, such as $1. When I have this one, this x, that's going to mean x of something, or x dollars. For example, this could be, x could be $5, 5 of these. So x is some unknown amount of these. X squared is x squared of those dollars. So for example, if x was 5, x squared would be 5 squared, or 25 of these. So whatever x is, x squared is x times itself of these. Y is a different amount from x of these, and y squared is y squared of these. So whatever y is, y squared number of these. So with that said, when I have one of something plus x of something, I can't really do anything. The only way I could write that is 1 plus x. I can't make that 1x, I can't make that 2x, all that I can say now is I have $1, that I have $1 and x dollars. So how I would, if I saw something like this, that's just 1 plus x. There's nothing more I can do with that. I can add them, I just can't, say what that equals because I need more information. Now, nor can we add 1 plus x squared. That's just simply 1 plus x squared I need more information to say specifically what this equals. I can't say that this equals 2x squared because that would mean that I have two of these. But you can see I have one of these and one of these. This would be x plus x squared. There's nothing more I can do to that. It's just except call it x plus x squared. Since y is some number and since y is some number and x is a different number, the best that I can express that is simply x plus y. Now, what can we put together? If I have x plus x, all that means is 1 of x plus another x. So we would say x plus x means that I have 2x, so that I can actually put those together. So we consider x and x, since they're the same thing, same variable to the same power, to be like terms. And here I have x squared plus x squared. I can put those together too. What do I have? I have 2 of x squared. So those are very simple algebraic expressions that I have combined their like terms because they are like terms. They have the same variable taken to the same power. So long as I'm putting together terms, so long as I'm putting together terms that are like, again, that means same variable taken to the same power, if I put those together, I'm performing a legal and helpful action in algebra. So what the task when you see an expression like this one right here of 2x plus 3 plus 5x plus 2x squared, what I can do to this, I'm not going to do what we did in the last mini unit, which was to would give you the value of the variables and find out what all this equals. This case, I'm going to do what's called simplify the algebraic expression. Now, what I have here is I've modeled with the manipulatives what I have up here above. This right here is the 2x, 2 of the x's. This is the 3 1s. This is the 5x, and this is, actually I need to add one more of these. I'm short one, so let me just add one more x squared here because it says 2x squared there. And I'll try to fill this in with yellow real quick. Sorry about that. So I have, and that's my 2x squared right there. And so visually it's pretty obvious what goes together here. I can put together these two x's with these 5 x's, but otherwise I can't put together ones. I can't put together these ones with these x squareds, nor can I put together these x's with the x squareds because they're non-like terms. So basically what's really going on here is I'm rearranging this equation, or not this expression, to put my like terms together, but I don't have to actually do this when I'm doing the homework, but in this particular case I'm kind of doing this in my head and I'm realizing that 2x plus 5x equals 7x, so I put together, what I just did right there was put together this 2x and this 5x, and I can't do anything further with this expression except add the other parts. There's nothing else I can do because it wouldn't depict what we actually have here, which in the end we simplified this expression by putting together the 2x and the 5x, the 2x and the 5x, and making that 7x, and that's all that we could do that truly tells us what is here. Now, so when I'm actually doing this in the homework, what I tend to do is just use a lot of geometric shapes to kind of pair up my like terms, or sometimes there's more than 2 like terms, but this, I've modeled an algebraic expression and ask you to think about, before I actually write it down, what is actually here, and then we'll decide if we can simplify it, if we have any like terms. So what I would like to point out is that these are 4 1s, so that's simply going to be 4. Then I have this x squared right here, and I'm going to say plus x squared. Then I have these 3 1s right here, so I'm just going to add 3 more 1s. Then I've got these 2 x's right here. I'm going to say plus 2x. I got these 2x squareds right here. I'm going to say plus 2x squared. And then I've got these 3 x's right here. I'm going to call that plus 3x. Now, instead of moving things around, which I'm really doing this in my head, moving them around, by what I'm going to do is put some geometric symbols around what I consider to be like terms. Anything that goes with this 4 are standalone numbers. We also call those constants. I'm going to put a triangle around. So the 4 and the 3 are the 2 standalone numbers in this expression. I'll be able to put those together with addition. I'm going to put rectangles around anything that has an x squared in it. So I have an x squared without a number in front is just 1x squared, and I'm going to put ovals around anything with just an x without the x squared, without the 2 as the exponent. So if I put the 2 triangles together now, the 4 and the 3, I get 7. So that came from, so what that was these 4 1s and these 3 1s, and that's where the 7 came from, 7 1s. And then I have x squared and I have x squared and 2x squared, so that's going to be plus 3x squared. And again, we can see that above because that's this x squared right here that goes with these 2x squared, so there's your 3x squared. And then all that I have left are these 2x's right here and these 3x's right here. And so I'll put these 2x's and these 3x's together, and that gets me plus 5x, and that's how I have simplified this algebraic expression right here by calling it 7 plus 3x squared plus 5x. And this technique I used works really well of putting giving geometric shapes to your sets of like terms and then putting them together in your final answer. So that would help us with this particular example. If I have 2x minus 7, notice instead of 7 green ones, I have 7 red ones reflecting the minus 7. I have minus 5x instead of yellow ones, I have 5 red ones, and then I have plus 9 green ones. Remember, anytime that I can pair up positives and negatives, for example, if I take 2 of these and 2 of these, those 2 x's and these two negative x's make 0, so they are out of the picture now. And then I have, over here, I have 7 negative ones. I'm going to pair those up with 7 of these positive ones, and that means those can now go away, but leaving 2 extra positive ones. So all of this expression above, if I use my geometric shapes now, remembering that subtraction signs give the term, the sign of the number. So I'm going to use triangles around the x terms. I'm going to include that negative right there, and I'll use an oval around that, except I got to go a little thinner here. Seems to not want to. Let's see if I can erase that. Try a little thinner since I don't want to write over the numbers there. So I'm going to put a triangle around that and a triangle around that, and I'll use an oval around that and oval around that. And you can see the 2x and the negative 5x, that actually is going to get me negative 3x. Let me get this a little thicker now. That's going to get me negative 3x, and that's reflecting these right here. And then I have negative 7 plus 9, so there's 2 extra ones, and that's my extra 2 ones right there, so that's plus 2. So that algebraic expression above simplifies to negative 3x plus 2. So let's try to identify what this one would be. So what algebraic expression is it, and can I simplify it? I think you're going to realize the answer is yes. So the four green ones make a positive 4. The 2x squareds just is plus 2x squared. The 3 negative x's are going to make minus 3x. Then I have these 3 negative x squared, so I'm going to say minus 3x squared, and then these 3 negative ones, that's going to be minus 3. So lots of 3's in this problem. Now then I'm going to identify my like terms. I'm going to put these 4 ones, or actually I can only use 3 of those, right? Because I only have, so I have 3 of these 3 negative ones over here, and that can zero out 3 of these positive ones. And so what that is, that's dealing with this and dealing with this. And then I have these 2x squareds, and I can use 2 of these negative x squares to cancel those out. So I'm going to do 2 of these, and 2 of these will make 0. And then I'm left with these, and then I'm left with these 3 negative x's that don't have anything to partner up with. So you'll notice in the end what I really have are, let's use purple here. So I have this 1 right here, and I have these 3 x's, and I have this 1 negative x squared, and we can see down below that that's what I have if I use these geometric shapes. So I'll put ovals around these 2x squareds and this negative 3x squared, and then I don't have anything else for this. I'll just use a rectangle around that. So the 4 and the negative 3, as we said above, make positive 1, and the 2x squared and the negative 3x, there's one more negative x squared, that's that one right there, so that's minus x squared. And then I have this these 3, I forgot about these 3 negative x's, that's reflecting that one right there. So that's reflecting this standalone negative 3x. It didn't have any other like terms, so I just have to bring that along, so minus 3x. So that's what that simplifies to. So very quickly, let's do this next example. So if this is 5x plus 2y plus 3 minus 3x minus 4, I can, well, put triangles around the 5x. There's a negative 3x there. I'll put ovals around the 2y, nothing else there. And let me put rectangles around this. So you can see I've got 5x and negative 3x, so I've got 2 extra x's. If you look above, I won't mark it this time, but you can see that makes sense. 3 of the x's cancel out 3 of the negative x's. Then I have 2y that doesn't have anything to go with it, and then I have a positive 3 and a negative 4. I've got an extra negative 1 here, and so that's how that one simplifies. At the end of the assignment, there's some information on the distributive property, and you'll need that in some simplifying on a couple of the problems toward the end of the assignment. Basically, the distributive property just says you've got an expression. In this case, this is 2y plus 3. And I'm going to take that and I'm going to multiply it by a certain amount. In this case, let's say 3. So everything I have in the parentheses, I'm going to multiply by 3. So remember, this 3 on the outside says how many I want of this and how many I want of this. I want 3 of 2y plus 3 of 3. So that's going to mean if I triple everything in the inside, I triple both the 2 y's and I triple the 3, and I end up with 6y, and this is the distributive property that does this. I'll have some more examples that show you that. So that's how you simplify using the distributive property. Anytime you see a number outside of a sum or a difference in the parentheses, you just want to distribute it to both items with multiplication, and it just says how many you want, what kind of multiplier effect you want of what's inside the parentheses. If I have 2 of x and 3, so I want 2 of the x plus 2 of the 3, and that would get me 2x plus 6. I just doubled everything that was in the parentheses. All right, in this next example, I have 3 items on the inside. So I have 3 items on the inside. X, so I have x, y, and 2. This 3 means I want 3 of everything. So I'm going to say 3 of x plus 3 of y plus 3 of 2. So 3x plus 3y plus 6 would be how I'd simplify that expression. I can think of this one over here as 2 of y minus 2 of 3. That's the way I want to think of that if I have a subtraction sign. So I'm going to say 2 of y minus 2 of 3, and that's 2y minus 6. The only difference between this and a previous problem was I had this minus sign. So that's how that simplifies. And so the most complicated expressions you'll see tonight are there's a couple toward the end where it has distribution, it has distributive property coming in effect, and also just 2 or 3 other terms that aren't affected by this multiplication by 3. So what I want to do here is I want to deal with this part first. Before I try to put any like terms together, I've got to use a distributive property here. That's always going to be your first step. So I'm going to say 3 of x plus 3 of y plus 4y minus 5x. So 3 of x means 3x. And 3 of y means plus 3y plus 4y minus 5x. So my like terms here are 3x and negative 5x, and then I've got 3y, and 4y. So if I put my x's together, I've got 3x and negative 5x. That's actually going to be negative 2x. And I've got 3y and 4y. That's going to be plus 7y. So that's how you would do one like that. All right, that is the end of the lesson.